Welcome to edupediaworld.com. You're watching the videos on probability. So in this video again we'll discuss some of the more extra questions related to probability, so which are very important again and generally seen in the examination. So you have to watch this part of the video very carefully again, right? So let's discuss the first question, which is question number 1. Now the question says that two dice are thrown simultaneously 500 times. Each time the sum of two numbers appearing on their tops is noted and recorded as given in the following table, right? So let's say suppose on one dice it comes 1, on another die it comes 2, right? So 1 plus 2 is 3. So this means sum is 3 and the frequency is 30. So this is how the data is given. So first you need to understand what kind of data is given, right? Now the question says that if the dice are thrown once more, let's say this even happens once more, right? So we need to find what is the probability of getting a sum of 3, first part. Second part says that more than 10, less than or equals to 5, and the fourth part is between 8 and 12. So let's say how we can solve this question. Very interesting question, right? Now first part says the sum is 3, so we can say that frequency with sum equals to 3, right? So how much is given? It's given 30, right? You can see properly. Now we can say that now probability with sum equals to 3 equals to frequency, whatever the frequency is given for the sum, equals to 3 upon total of frequency, right? So this will come out to be 30 upon 500. So when you solve this, it will come out to be 3 by. So this is how we have to solve this question, right? Now the next part says that what is the probability that it's more than 10? More than 10 means we have to consider 11 and 12, right? So this means we have to add this frequency and this frequency, right? We can say that frequency with sum more than 10, it will be equals to 28 plus 15. This equals to 43, right? So we can say that now probability with sum more than 10 equals to frequency, right, with sum more than 10 upon total of frequency, right? So this will be equals to 43 upon 500, right? So this is how we solve this question, right? Now the third part says that it's less than or equals to 5. So less than or equals to 5. So this means we have to add all this frequency, right? So we can say that frequency with sum less than or equals to 5, it will be equals to, we need to add all this. So let's add it. So it will be 55 plus 42 plus 30 plus 14. When you add them, it will come out to be 141, right? So we can say that the probability with less than or equals to 5 equals to frequency, whatever the frequency is, upon total of frequency. So this will be equals to 141 upon 500, right? Now the last part says that between 8 and 12. So it's very tricky part over here. So let's see how we can solve this, right? Fourth part says that it should be between 8 and now it's not given between 8 and 12, right? So this means we have to consider this part only. We cannot consider 8 and 12. Why? Because it's clearly saying that between 8 and 12. So this means we have to exclude this part and this part, right? So we can say that now frequency of sum between 8 and 12, it will be equals to, let's say 53, right, plus 46 plus 28. So when you add them, so let's add them, how much it comes out to be. So 53 plus 46 plus 28, so will be 17, right? So it will be 127. So we can write it over here 127. So we can say that the probability between 8 and 12, so it will be equals to frequency upon total of frequency. So it will be 127 upon 500. So this is how we have to solve this question, right? So let's move on to the next question, which is question number 2. Now the question says that a company selected 4,000 households at random and surveyed them to find out a relationship between income level and the number of television sets in a home. The information so obtained is listed in the following table. So this is the table in which monthly income and number of televisions in the households are correlated, right? So we need to find the probability of household earning 10,000 to 14,999 per year and having exactly one television. Second part says that of household earnings of 25,000 rupees and more per year and owning only 2 televisions, right? Now and the last part says that of a households not having any television, right? So let's see how we can solve this question. Do it very quickly. So first part says that let's say we need to count a household earning between 10,000 to 14,999 per year and having exactly 2 televisions. So this will be the data, right? So we need to consider for 2 televisions. So this is the data, but we need to consider only 1 television. So this will be the point, right? So we can say that number of televisions of household earnings from rupees 10,000 to 14,999, it will be, and have one TV set, right? So it will be 240, right? So we can say that the probability having exactly one TV set and earnings, let's say earnings between 10,000 to 14,999, so it will be equals to whatever the frequency is given. So it can be, say, number of TV sets upon total number of households that were surveyed, right? So this will come out to be, let's say, 40 upon 4,000. You solve them, right? So it will come out to be 3 by, right? So let's do the second part. The second part says that of a household earning rupees 25,000 and more per year and owning only 2 televisions, right? So this is 25,000 and above, right? And 2 televisions. So this will be the data, right? You can say that over here, number of TV sets of household earnings, let's say 25,000 and above is 760, right? So we can say that probability of household, right, of 2 TV sets and earnings 25,000 and above, right, we can write like this, will be equals to number of TV sets, right, whatever the frequency is, and the number of household surveyed, we can say like this. So this will be equals to 760 upon 4,000. So cancel it, you simplify it, come out to be 19 by, right? Now, so let's do the last part. Now the last part says that of a household not having any television, right? So now it doesn't matter how much is the income, but it matters only it doesn't have any television, right? So we have to sum all this data, right? So you have to be very particular what type of question they are asking. So that's all about the probability and statistics, right? So we can say that number of house not having any TV set, so it will be equals to 20 plus 10, so it will equals to 30, right? So we can say that probability no television set, right, no TV, we can write simply equals to number of household with no TV set upon total number of household, right? So this will be equals to 30 upon 4,000, right? So when you solve it, it will come out to be 3 by 400, right? So this is how we have to solve these type of question. Now let's discuss the next question, question number 3, and which is also a last question of this video. Now the question says that, very interesting question, right? So please watch this question very carefully. Say here is an extract from a mortality table, right? So let's say age is 60 and the data given is number of persons surviving out. It's not the number of person dying, right? So number of persons surviving out of a sample of 1 million. So you have to be very careful, right? Now based on this information, what is the probability a person age 60 of dying within a year, right? So let's see how we can solve this question. So first part, we need to find how many are person that age 60 dying within a year, but the data given over here is survival, right? So and total data that is surveyed or sample is 1 million. So 1 million is 10 lakh in Indian system. So we can write over here 10 lakh, right? So it's 1000, right? So that's 10 lakh. Now first of all, we need to find the data. So we can say that number of persons, let's say, dying aged 60 within a year, it will be equals to 10 lakh, right, minus 16090, because these many people are surviving out of 1 million, right? So this means 10 lakh, when you take away 16,090 from 10 lakh, so this means these person must be dying at the age of 60, right? So this is how the data works. So when you solve it, it will come out to be 983,910, right? So it means 9,83,910. So this is the data, or say we can say number of person dying at age 60 within a year, right? So we can say that now the probability person aged 60 dying within a year will be equals to number of persons dying age 60 upon total of sample surveyed. So this will be equals to 983,910 upon 10 lakh, right? So when you solve this, it will come out to be 0.98391, right? So this is the probability that a person age 60 dying within a year. So now let's see how we can solve the next part, the second part. right? Now what is the probability that a person age 61 will live for 4 years? So it's a very tricky question how we can solve this. Let's now this data is given for the person living for a year, right, surviving for a year, but now we have to find the probability age 61 will live for 4 years, right? So we first of all we write over here number of persons or surviving aged 61 within a year, it will be equals to 11490, right? So we can write now over here we can find the probability person aged 61 living within a year, it will be equals to number of people, or we can say number upon total sample surveyed, right? So this will be 11490 upon 10 lakh, right? So when you solve it, it will come out to be 0.01149, right? Now over here we have to find the probability the person age 61 will live for 4 years, right? So we can say the probability that a person aged 61 will live for 4 years will be equals to, now this is the probability for 1 year, right? So this means we have to multiply this probability for 1 year for 4 times. So this will be 0.01149 times 0.01149 times, so 0.01149 times 0.01149 times. So it's a rule of multiplication that we have to apply in this question. So when you solve this, this will give you the probability that a person age 61 will live for 4 years, right? So this is how we have to solve these type of question. So in the end, I can say that thank you once again for watching this video on edupediaworld.com. Keep watching for the videos. Have a nice day ahead.